welcome back to Math 9. Today we're going to be looking at 4.2, which is linear equations. But before we can do that, it is very important that we review how to plot points on a Cartesian plane. As we're going to be working closely with graphs in this next couple sections, it's important that you understand and remember how they work. So if I'm looking at this, I'm looking at a single quadrant of the Cartesian plane. We should all remember that 0 is over in the corner all the time, and the bottom line is considered our x-axis, while our vertical line is always considered to be our y-axis. When we are putting numbers on our Cartesian planes or our graphs, it is very important that we are going up in even increments. What that means is I can't just jump all over the place and change numbers. So I'm showing that I counted up by 1 each time on both sides, and it's okay if your scales are different as long as they are consistent on each of those axes. So you could count by 2 if you wanted to, or by 5, but you have to make sure you're counting by that same amount every time, or else it kind of distorts our information. So if we look at how we plot points on this, and I gave you guys kind of an example of something that we would be seeing. So they might give you a table of values, either horizontally or vertically. So I give you a vertical one. If it is vertical, your top number is always your x, and the bottom is always the y. If they are giving you a vertical one, it is x and y. Okay, so it's important that you kind of make that distinction of when you're going to be plotting it onto your graph. So if I have a figure number 1, and in that there is 3 blocks, I am going to find the 1 on the x and 3 on the y and put a point. Okay, for the second one, the figure number 2, the number of blocks was 5. So I'm going to go to 2 and 5. 3 and 7. And the last one was 4 and 9. Okay, so it's very important that we remember how to plot our information onto a grid in order to solve what we're going to be doing. So at the bottom of this, I do have a little side note. How can we use this graph to predict the future numbers? So if you're looking closely at it, you guys should be able to see that I kind of have a straight line going. So if I were to continue my line, would you be able to tell me what it would be for 5 or for 6? Okay, so oftentimes if we are properly graphing things, it does help us figure out our equations and our patterns a little bit more clearly. So 4.2 is specifically looking at linear relations. So a relation is just a rule that associates two things. I have a little bit of French in here for you. Okay, so it's just a rule that associates two things to each other. A linear relationship means that when it's graphed, all the points can be found on one straight line. Okay, so there's a couple examples down here for you. So if I'm looking at this chart here, what they did is they took each of these individual tables of values and they graphed them onto a line. And you can see that every one that is there did create a straight line. Whereas if I'm looking at this example over here, I can see that while there's points nicely plotted onto this grid, they're not all in a straight line, so it does not have a linear relationship. Okay, so this is that other one just blown up a little bit. So you can see I got -2, so if I'm looking at this first one.
Students that are waiting outside,
Sorry.
Can you check if you've lost a house key with a keychain that says Redstone on it?
Sorry for that interruption. So if I'm plotting -2, -4, I'm looking for -2 and -4 down at the bottom, which would be right here. If I'm looking at -1, -2, so my next one, -1, -2 would be right here. If I'm looking at 0, 0, it would be right here. If I'm looking at 1, 2, I'm finding the 1 and then the 2. Can you see what line they would be connected to? And then you can see that they did label it to show you that that is representing that table of values. So we're going to be looking at these, and as you guys are working, this may be a method that makes it a little bit easier for you, is to use the same grid for multiple equations. And if you are doing that, make sure you are clearly labeling as they did here. So are these linear? If you were to graph these on a Cartesian plane, would they make a straight line? Okay, so if you want to pause this and actually go and graph, take out a piece of paper and put them on, you can free to do so. When you're ready, you can join us again. Those of you who are here and back, when we are looking to see if something is linear, there's two ways that we can do this. You can graph them to see if it makes a straight line, and two, you can look at the pattern. If there is a set pattern, it should make a straight line. If you do not have a set pattern, it does not make a straight line. So I'm looking at this first one. I go up by 2, I go up by 4, I go up by 6, I go up by 8, and while it's going up each time, it's not going up by the same amount. So if I were to actually graph that into a grid, I've got kind of 1, 1, 2, 3, and then 3, 7, and you can see that I'm just going to be like going up and increasing quite quickly as I go, which makes a curved line. So the first one, not linear. The second one is going up by 3, and 3, and 3, and 3. And this side goes up by 1 each time. So because I can see that there is a set pattern, if I were to graph this one at 1, 3, 2, 6, 3, 9, and I had it all properly numbered, it would make a straight line, telling me that it is a linear relationship. Okay, so the little trick, the little hint that helps you out, if there is a set pattern in the x and the y, it will make a linear relationship. This will also help you to see if you were doing things correctly or not, because if it tells you it is linear and you get an image or a picture that is not, then you know that you made a mistake somewhere and you can go back and correct it. So if we go over just one last example, they will often give you an equation. From that equation, they will ask you to create a table of values. And once you have a table of values, they will ask you to graph it. So this is my equation, y equals 5 minus 3x. To figure it out, I need to use substitution 5 different times. So I'm going to say 5 minus 3 times negative 2. So 3 times negative 2 is negative 6. And 5 minus 6 becomes plus, becomes 11. So y is equal to 11. If I did for the second one, 5 minus 3 times negative 1. 3 times negative 1 is negative 3. And 5 minus negative 3 plus gives me 8. 5 minus 3 times 0, 5 minus 0.
Reminder to all staff that we need a quick staff meeting at 3:35. I'm going to set.
Sorry for the interruption. We were saying 5 minus 3 times 0, which becomes 5 minus 0, which gives us 5. And if I did the next one, 5 minus 3 times 1 gives me 5 minus 3 times 1 is 4, which gives me 1. And if I did the last one, 5 minus 3 times 2 becomes 5 minus 6, which gives me negative 1. So if they're going to give you an equation, they will ask you to do a table of values. And to do that table of values, you will have to solve them out by substitution. Once you have your table of values, and you can see the numbers that you are working with, you can create your Cartesian plane. So we know that 0 is always in the middle. And because my x is only negative 2 to 2, I can just count by 1 in both directions, because there's enough room for me to do that. On the sides, I need to go all the way up to 11 and -1. So I can still, because 11 is not actually that large, I can still just count by 1 each time, even though it might not necessarily work on where I place it on my board. All the way at the top. And then I'm just going to plot my points. So I'm at -2 and 11, then I'm at -1 and 8, 0 and 5, 1 and 1, and 2, and I don't have -1 down here, -1. Now once you plot them on your nice Cartesian plane graph on grid paper, and not just blank paper like this, you should see that if you drew a line, it should be straight. And this one would actually be straight had I measured it out properly. Okay, so that is how you verify that you've done it correctly. Okay, so once again, there are a few practice questions in your textbook. You're not expected to be doing every question that is here, but this gives you a general overview of everything. So as you're starting, it's very important that you're reading each of these questions. And if something is repetitive and you understood it the first time, then you are free to continue on to the next part. Please let me know if you have any questions or concerns, and I will be happy to answer them for you. Have a great day.